Welcome to the Ocean Today Every Full Moon Watch Party with marine science educator and host Simone Barkley, live from her home in Baltimore.
Today we'll be exploring wild weather events around the world with NOAA climatologist Tom Di Liberto.
Tom will show how typhoons in the Pacific Ocean helped whip up the catastrophic megafires that devastated many communities in the western U.S.
We'll break down how the growing La Niña in the Pacific and extremely warm water in the Atlantic and Gulf of Mexico are contributing to an exceptionally active hurricane season.
And NOAA's lead seasonal hurricane forecaster, Dr. Gerry will help us understand how the study of ocean and atmospheric conditions helped his team predict this year's relentless hurricane season.
Here at Ocean Today, we respect your privacy. The show will be recorded, but viewers will not be shown on camera.
We love your questions and feedback, so feel free to use the chat box.
Join us next full moon and creep into the deep with NASA and NOAA scientists as they explore extreme ocean worlds here on Earth that might lead to clues for life on other ocean planets.
Let's get started with our first Climate Alive video.
Welcome! We're about to take a tour of the weather and climate across the planet since the middle of August. Well, at least across half the planet. We're taking a look right now at a satellite picture of the Pacific Ocean. On the left, you have Asia, and on the right, you have the United States. And the interesting thing I'd like to talk about here is that we have two typhoons in the picture that are going to cause some interesting issues for weather across the United States. Yes, weather thousands of miles in the western Pacific Ocean can affect the weather across the United States. Watch specifically the middle part of the Pacific Ocean. You see right here how the clouds are basically from west to east across the Pacific? Watch how that changes after these two storms make landfall in Korea. Now we see, as opposed to that west to east cloud bank across the Pacific Ocean, it's gotten super duper wavy. And that super duper wavy is basically what we see as the jet stream. What this can do is cause big areas of high pressure along the west coast of the United States. That's the crazy thing about our planet. What happens here doesn't stay here because everything is intertwined with the way the winds move across the entire planet. Now we're just taking a look at the United States here. Look at all of the smoke from the wildfires out west. The interesting thing to look at, a few days after Typhoon Haishen made landfall in Korea, is that big area of white along the Canada-United States border. This represents a big low-pressure system and a cold front that's about to push south across the United States. And what this will do is basically whip up the winds and allow those wildfires to expand and that smoke to get even bigger. And notice how huge the smoke is now as the wildfires got set off in Oregon and Washington, stretching all along the West Coast. At this point, in California and parts of the West Coast, zero sunlight. No sunlight was reaching the surface. It was some of the worst air quality in the entire world. And as we're moving across the country, you can see that smoke get pulled into these other storm systems as they're moving across the United States. In fact, some of the hazy skies across the eastern seaboard were caused by smoke from the West Coast. What else do we have in this picture? I count two separate hurricanes occurring in the Atlantic and the Gulf of Mexico. And this is Hurricane Sally, made landfall as a Category 2 storm, dropping feet of rain across Louisiana and the Gulf Coast and Mississippi. Now, far off into the Atlantic, that's Hurricane Paulette. Now, as Paulette moves over colder waters of the oceans, it weakens. But while doing so, it drags in the smoke from the wildfires out west and actually brings them all the way to Europe. Now, this is a story of extremes, of extreme wetness when it comes to the hurricanes on the East Coast. Meanwhile, extreme dryness and heat and fire across the western United States, while smoke is dominating the picture coast to coast. Now, it's been an incredibly active hurricane season, one of the most active hurricane seasons on record. And this is taking a look at the hurricane season going back to the middle of August. The average number of storms that we normally see is 12, and we're well past that by this point. Every storm that I mention from here on out represents the earliest time we've ever reached that letter in the alphabet when it comes to hurricane. In fact, all of these hurricanes make the season above average. We reached average in August. The peak of the hurricane season is normally in the middle of September. The most dangerous storm was Hurricane Laura. Do you see that big area of storms right in the middle part of the frame? That's Hurricane Laura. Now, it doesn't look like much now, but wait until it gets into the Gulf of Mexico. It taps into really, really warm water, and boom! Eye pokes out, Category 4 storm at landfall in parts of Louisiana and Texas. Incredibly damaging storm. Second week of September, you can see multiple storms starting to pop out. We have Hurricane Paulette now across the middle of the Atlantic with Tropical Storm Renee just behind it. While your eyes may be looking at the Atlantic Ocean, there's another storm forming over Florida. That's Sally. Now, Sally strengthens to a Category 2 storm right here and makes landfall in Louisiana, while Paulette and Renee weaken across the Atlantic Ocean. On September 17th, all of this area to the west of the remnants of Hurricane Paulette is smoke from the wildfires. That's burned trees, that's burned grass, that's burned brush from the west coast showing up in the air over the middle of the North Atlantic Ocean and soon to be over parts of Europe. This is Beta making landfall across Texas. Yes, that's right, Beta. We used up all of the letters of the alphabet when it came to our hurricane names, and we had to dip into the Greek alphabet. It's only happened one time before in 2005, but we're already into the Greek alphabet, and that's Beta. This is a zoomed-in shot now of Hurricane Laura, the strongest hurricane that's happened so far this year in the Atlantic, and it rapidly intensified. When a storm gets very, very strong, a hurricane gets very, very strong, the center of the storm actually clears out in what's known as the eye. And you can notice how fast the winds are whipping around the center of that eye. Around that eye, those clouds make the strongest part of the storm. That's the eye wall. That's the strongest thunderstorm. Now, we have to send hurricane hunters through the worst parts of the storm, the eye wall, to get important information to allow our forecasters to make the best forecast. But as you can see, a little airplane's no match for a big hurricane, and Hurricane Laura tossed that plane around, but it still managed to make its way through into the middle of the eye. The data that they can get through the hurricane can be fed into our weather and climate models to allow us to better predict storms, specifically understand how strong that storm is and the potential damage it can lead to causing across the United States. Thanks. And that was just a short amount of time to talk about a lot of stuff that happened across half the planet since the middle of August. Simply put, there are crazy things happening, from typhoons in the Pacific to wildfires out west. And meanwhile, we're experiencing one of the most active hurricane seasons in the Atlantic Ocean's history.
Hi, everyone, and welcome to today's watch party. We are going to be learning a lot about wild weather today and watching some videos. And of course, we'll be joined by two experts today. So if you don't know, my name is Simone, and I am the host of this show. And I'm so excited to be back with you all again for another month of our watch party. Today, we are going to start out with our first guest, Tom Di Liberto, who was in the video that we just watched. And Tom is a climatologist and science communicator, which means that he likes to talk about science and make it easy for people to understand. And he's working as a consulting climatologist and social media editor for NOAA's climate.gov. And he loves to talk about the ocean, weather, climate, and those connections. So we want to say welcome to Tom.
Hi, Simone. How are you?
I'm good. How are you?
Not too bad.
Great. It's so nice to have you with us. And I think it's really cool. I just want to say I think it's really great that, you kind of deem yourself a science communicator. That's something that we talk a lot about, these days, about how, scientists can also be science communicators, and they don't just have to do research. And so I'm really glad that we might be having students here who are listening and learning and thinking about how they might be able to have a job like yours, especially even working in social media, where a lot of times people think social media is just for fun, but it could be your job, right? And you could be communicating science there. So thank you for showing us a little bit about your work.
Thank you so much. I've loved it so far. I started as a scientist, I got more into science communication, and now I get to do social media too. I get to do everything. It's fun.
Yes, fun, and that's fantastic. So Tom, thank you so much for joining us again. I just wanted to say before we get into some of the things we're gonna talk about, um, I wanted to make a note, to make sure that everyone knows that we fully recognize, the extremities of the weather and the impact that it's had on folks across the country. And so we want to just make sure that we are acknowledging those things, and that we want to talk about how those situations form, and how we can be prepared for those things in the future.
That's exactly right.
Great. And so I had a few notes from that video. So one, and I actually saw someone ask a question about this, right? One person asked, what happens if we go past the Greek alphabet? And I think that they were asking that, because, because you had said, that we have already moved on to the Greek alphabet this year, and we're making history right now.
Right. I honestly don't know. I'm not sure they would know. I mean, in 2005, the only other time we've went through all of the regular alphabet and then we've gone to the Greek alphabet, I think we ended at Zeta, which is the sixth storm in the Greek alphabet. We've never gone past that. So I would hope. My answer to you is a hopeful one, that we do not have to even worry about it. Because honestly, I don't even know. I was joking around, maybe we'll go into Pig Latin, but honestly, this is all kind of new. This is the earliest we've ever reached the Greek alphabet. We've only reached it one time before. But the Greek alphabet gives us a good amount. I'm not exactly sure the exact number, but we get into there's an additional teens or so of additional storms potentially. So hopefully we don't have to worry about it, because I'm not sure we know the answer to that. At least I don't know the answer to that.
That's fair. That's okay. Fingers crossed that we don't have to get there, right? And thank you for saying, that you don't know the answer, Tom, because I also think that's important for, students and people to know that we don't always know everything, and it's okay if you don't know. It's okay to say, I'm not sure. That's perfectly fine. That's a good lesson in science communication and being a scientist, is just saying what you know and what you don't know, being honest. And so in that video, you also shared, that we were starting to see hazy skies on the East Coast from the smoke and the fires that happened on the West Coast. And I think that's crazy and fascinating that, it was able to travel across the country.
Yeah, it's pretty amazing. Now, the smoke is different in the sense where on the West Coast, that smoke was from the ground all the way up. The smoke, basically, once it rises really high up in the atmosphere, it basically can get carried by the jet stream, which is this place 40 to 50,000 feet. It's basically where planes would fly. Once they get stuck up in that jet stream, it can travel across the entire country. And yeah, so if you're on the East Coast, you may have noticed there are some really vivid sunsets, really red and colorful sunsets. A lot of that was from the smoke that was happening way off on the West Coast. It's incredible how everything can be interconnected.
Wow, yes. So amazing. So since we've kind of gone through a little bit about the video that you just shared with us, we want to go into our first poll question that we have for the audience, okay? So this first one that we have is, when was the last time yearly temperatures were cooler than the 20th century average? When was the last time yearly temperatures were cooler than the 20th century average? And the choices that you have are 1937, 1954, 1976, and 2018. Tom, do you want to give them the hint that you, or reminder that you like to give about the 20th century and what that means?
Sure, because this always makes me stumble too. The 20th century average is talking about the 1900s, that entire century, from 1901 to 2000. That's the period of time we're looking at here. That's the 20th century.
Thank you for that reminder, Tom. Tom wanted to give that reminder to everyone. So it looks like we have the results coming in, and looks like most people have voted so far. The poll is now closed, and these are some pretty close numbers, right? We got about 33% of people saying 1937, and then 36% saying 1954. So really close. Tom, would you like to share the answer?
Sure. The answer is actually 1976, or said another way, 44 years ago was the last time a yearly global temperature was lower than the 20th century average. Can I tell them the secret about why I chose those years, Simone?
Go for it.
I found this fact amazing when I thought about this. If you remember back to when the movie A Star is Born came out, starring Lady Gaga, it came out in 2018. That was actually the fourth time that movie had been made. And each of those years is a year when the movie A Star is Born was released. In 1976, that movie starred Barbra Streisand, not Lady Gaga.
Wow, isn't that kind of funny, right? That he picked years that the same movie came out multiple times. Yeah, I haven't seen any of them, so maybe now I'll feel inspired to watch them. So we just want to remind everybody that we are going to welcome your questions and comments. Just go ahead and type them into the chat box, and we'll queue them up so that I can try to answer the questions or ask the experts who are with us so that they can answer the questions. Okay, everyone? So please go ahead and put your questions into the chat box. So we're going to move on a little bit. So in addition to the winds from the typhoon blowing across the West Coast, what other conditions contributed to fueling the fires that we've seen?
Sure. So there's a couple of factors that go into creating wildfires. They can be hot a lot of the times, but you need a spark to set off a fire, right? So one of the major things that actually created all of those wildfires, especially in the middle of August and September in California, was what we see here, lightning strikes. We actually had a dying tropical storm kind of throw up some moisture and some thunderstorms across the Bay Area around San Francisco. And what it did, it was so hot and dry in that area, it would rain, but the rain would evaporate before it reached the surface. So it wouldn't feel like it was raining, but there'd be lightning strikes everywhere. And that lightning basically was the catalyst or the creator of all of that initial spark to create these crazy strong and big wildfires that were then picked up by the wind. So to make a really big wildfire, you need the spark from the lightning, and then you need really strong wind to basically take that flame and spread it everywhere. And basically, California had all of those things from pretty much the middle of August up until now.
Yeah, wow. So you kind of already hit on the fact that, that there were a number of like lightning strikes. You need lightning to help to fuel these fires. And I kind of liked what you talked to me about before was that, it's kind of like when you go camping and you have to start a fire, right? You need to, create a spark. So that was a really good way to help me remember it.
Yeah, exactly right. So like the winds or the conditions, the really dry plants are like the logs you put in a campfire, but it doesn't make a difference how dry those logs are. You need something to actually set them on fire.
Exactly. Perfect. So we, okay, so not only did we have, I see some questions coming in, so I'm going to ask them in a moment, but not only did we have, those wildfires, we also had some like fire and snow that was clashing, which I think is pretty interesting. Can you talk a little bit about that and how those types of events occur?
Sure. So getting away from the West Coast, it was just really hot in California. If you just go a little bit further to the east, on the other side of the Rockies in Colorado, it was 100 degrees in the beginning of September, and then 3 days later, it snowed. It snowed 3 days later. I would think I would have no clothes to wear because all of my winter clothes are somewhere in a closet somewhere. I would have no idea what to do. And basically that can happen sometimes along Colorado, especially in September and October. You get these really big weather whiplashes, go from really hot to really cold. But even saying that, going from 100 when all this warm air from the south comes up, and then basically having that completely shift and going to cold air coming down from Canada in 3 days, that's something you just don't see a lot of, going from 100 degrees to 4 inches of snow. And a lot of that is basically what we're seeing here in the video is the jet stream. I mentioned that earlier, but the jet stream kind of serves as a boundary. To the north, it's really cold, and to the south, it's really warm. And sometimes when it gets really wavy like this, you can get stuck under a warm part of it or a cold part of it. Colorado just got stuck under both of those things in 3 days and saw snow and wildfire heat very, very close in 1 week, less than a week, half a week.
That is crazy. I don't know how, you're right. I don't know how I would be prepared to leave the house, right? Because you might be dressed in one way, and then next thing you know, you have to bundle up. That's crazy.
Yeah,
Wow.
the good news at least was at least the snow was moisture, so it was able to at least tamp down a little bit on some of the fires in Colorado. Although I'm sure the fires are probably thinking they would see rain before they saw snow.
Yeah, probably. Probably. So you kind of mentioned jet streams, and we of course want to make sure that folks know that you can check out the National Weather Service Learning to learn more about jet streams and how they drive weather around the world. So you can see on the screen that we've kind of put up a screenshot of what that website looks like, and the links will also be shared. And when you go to the archive page, you will also be able to find those links and things. Perfect. Okay, so everybody, now that we better understand, the influence of how the ocean might contribute to megafires, now we're going to pivot to hurricanes. And I saw that some people have questions about hurricanes, so now that we're going to start getting into hurricanes, I'll make sure that I bring up those questions for Tom. So we're going to pivot to hurricanes, and we're going to learn a little bit more about how warm ocean water can help fuel the growth of a hurricane. So we're going to watch the Fuel for the Storm video from the Ocean Today Hurricane Survival Guide collection.
We've all heard that hurricanes are one of the most powerful and destructive forces on Earth. But did you ever wonder where they get their strength? The formation of a hurricane is complicated, but basically it depends on 3 factors. First, you need warm water, at least 80 degrees. The second ingredient is moist air. And finally, there needs to be converging winds for a hurricane to form. The actual process begins with a cluster of thunderstorms moving across the surface of the ocean. When the surface water is warm, the storm sucks up heat energy from the water, just like a straw sucks up a liquid. This creates moisture in the air. If wind conditions are right, the storm becomes a hurricane. This heat energy is the fuel for the storm. And the warmer the water, the more moisture is in the air. And that could mean bigger and stronger hurricanes. Satellite data shows the heat and energy transfer in action. Notice how this hurricane leaves a trail of cooler water behind. Scientists use sea surface temperature data from satellites to help forecast the intensity of storms. Hurricane Katrina, which was the 3rd largest to make landfall in the U.S., crossed over Gulf waters that had temperatures between 2 and 3 degrees higher than normal. This spawned sustained winds of over 140 miles per hour, extending 100 miles from the eye of the storm. And with greater intensity, there's a higher chance for death and destruction. This is why warming ocean temperatures matter. It's like adding fuel to a fire and taking the world literally by storm.
Perfect. So we just want to make sure that everyone knows that you can, again, use the chat box for your questions. And I actually want to ask you one question from the audience. This question is, how is climate change affecting the jet stream?
That is a super good question, a super interesting question, and that is a question people always often ask me, what are scientists still not 100% sure about when it comes to climate change? They may have heard lots of different things, and there's some stuff that we know. CO2, carbon dioxide is rising, the planet is getting warmer. One of those questions, a really active area of research, lots of scientists are studying this, is that exact question. You basically asked the question that scientists across the world are trying to answer right now. That's such a smart question to ask. Because, right, if climate change can affect the jet stream, that means it can affect the way weather and climate works across the entire world. There's some research that suggests that the jet stream is slowing down, going from, think of it like a really fast river. Like if you're near the Mississippi at a really fast point, it's going really, really fast. It pretty much goes in a straight line, versus kind of a slower, lazy, meandering river. That can have a really big impact if the jet stream could slow down due to climate change. The problem is we don't know if that's exactly true or not. There's some research that says, yeah, it's slowing down. There's other research that says we can't say anything right now. And that's one of the kind of interesting things when it comes to science. We'll learn more and more and more about this topic going forward because there's so many scientists learning about it, trying to figure out new ways of seeing it. I wish I could give you a more conclusive answer, but sometimes with really good questions like you just asked, sometimes the answer is a scientific, we'll find out. We're learning. We're trying our best to figure that question out. Because you're right, it could have a really big impact on our planet.
So again, Tom, you've again shown and demonstrated, right, that sometimes science isn't always like leading in one direction versus another. Sometimes we aren't really sure. We don't have enough information to make a decision in one direction versus the other. So that's why it's important that we continue to have people that continue to do this work and ask these questions and do the research so that we can be able to give a good answer that's pretty well informed. So we will now talk a little bit about marine heat waves, which are sometimes referred to as the blob, which I think is crazy because it kind of sounds like a monster or an alien or something. But what is this climate system and what kinds of teleconnections result when this is active?
Sure. So a marine heat wave, which can sometimes be called a blob, not by me, but by others, and that's that's fine. People call things whatever they want to call them, but it's referring to a marine heat wave, really. And a marine heat wave is similar to a regular heat wave you experience when it's just really hot outside, except that in this case we're talking about the oceans. What we're looking at here are the ocean temperatures and how different they are from average. So if you see red, it means the ocean is warmer than it usually is, and if you see blue, it's the exact opposite. Now look, just south of Alaska and the West Coast, there's a big area. It gets really, really red for a long period of time. That's generally what people consider the blob, but it's really called a marine heat wave. Yeah, up there. You see it kind of popping out. And what that is referring to is basically this connection between what's happening in the atmosphere, what's happening in the ocean. Sometimes you have, in atmospheric terms, a lot of nothing happening, or a big high pressure that sits there. It's clear skies, the oceans aren't incredibly wavy, and that basically allows the top of the ocean to get a lot warmer than it normally is because the sun keeps hitting it. And what that can do, it can kind of mess up marine life because marine life is used to temperatures being in a certain place. So when you warm it up, you can make it so there's less nutrients for animals to eat. You can create what's known as algal blooms. Algae can rapidly multiply and lead to a whole bunch of different issues when you mess up the bottom of the food chain. You start messing up all the different rungs of the food chain going up higher. And we've had lots of these marine heat waves over the last 5 years or so, especially in the North Pacific, which is what we're kind of looking at here. And yeah, this is kind of something that we don't talk a lot about, but can have a really big impact across the oceans and marine ecosystems.
Wow, interesting. Yeah, so I think it's important to talk about, and I'm sure people have been asking questions, right, about how it impacts like animals, right? How does it impact animals that live in the ocean? So I'm glad you were able to hit on that just a little bit. So thank you for teaching us a little bit about, these wild weather and these different experiences that we've seen across the world and the country this year. And so Tom is going to stay with us. He's not going anywhere, everyone. He will still be here. We are going to go into our next segment, right? And we're going to watch the next video, which is about the most famous climate system of them all. I'm sure lots of people have heard of it. Apparently, Tom has heard of it and really loves it too. So we're gonna. Did you do this?
I did. I love Enzo. Sorry, I already ruined it. Sorry, go ahead, Simone. I apologize.
Okay, you're fine. We're going to talk about El Niño and La Niña explained. So everyone tune into this video.
Warmer or colder than average ocean temperatures in one part of the world can influence weather around the globe. Boggles the mind, right? Here's how it works. During normal conditions, trade winds, which blow from east to west, push warm surface waters towards Asia, piling it up in the western Pacific. In some years, though, the trade winds weaken. The warm surface water moves eastward and reduces upwelling of cold water off the coast of South America. Climatologists call this El Niño. Its climate impacts show up mostly in the wintertime over North America. The warmer ocean fuels an intensification and southward shift of the jet stream. This brings flooding to the southern United States and warmer, drier conditions over parts of the Pacific Northwest, northern U.S., and Canada. But eventually, those trade winds pick up again and sometimes become even stronger than normal. When that happens, they blow the warm water back into the western Pacific and restart the upwelling of cool water towards the surface in the eastern Pacific. These strong trade winds are a signature of what is called La Niña, unusually cold conditions in the tropical Pacific that displace the jet stream northward. La Niña can lead to drought in the southern U.S. and cooler temperatures, heavy rains, and flooding in the Pacific Northwest. El Niño and La Niña together are part of a cycle that influences extreme weather and can impact food production, water supply, and even human health, not just in the U.S., but in many parts of the globe.
We are back with Tom Di Liberto, and he is a climatologist and science communicator, and we are talking a little bit about El Niño and La Niña. So thank you, Tom, for joining us. And to wrap out that video that we just watched, we are going to put up another poll for you all. So remember, if you see the poll, that you want to go ahead and choose your answers. You want to just choose the answer that you think is correct, and then it will be submitted, and we will get a notification, all right? So the question is, El Niño and La Niña are two parts of what's known as ENSO. The EN stands for El Niño. So what does the SO stand for? Super odd, southern oscillation, stratospheric offering, or seesaw occasion. It looks like the poll, I see that. It looks like the poll has different answers than what answers that that I gave you. So how about we just have Tom go ahead and give you some information about it, and he can make the connection.
Sure. So, so you want to give the answer to the and then talk about this one. The cool thing. So I think those answers, we can talk about all of those things. So El Niño, SO, it refers to the southern oscillation, because when we talk about El Niño and La Niña, it's not just in the ocean, it's happening in the atmosphere, as you learned in that video. And El Niño part of the phrase ENSO refers to the ocean, while the southern oscillation is referring to the atmosphere. Now, the answers to that question, we're probably asking where in the oceans, what ocean does ENSO really start in? And the answer to that is the Pacific Ocean, the biggest ocean. And yeah, it's this huge thing that happens across the tropical Pacific Ocean, but it doesn't just stay in the tropical Pacific Ocean. It's basically the first atmospheric domino to fall, and then that can cause all sorts of interesting things that can happen all across the entire world just from one thing happening in the Pacific Ocean.
Again, talking about how one storm or something can occur in one place and get all the way, right, across the country or across the world. That is, again, amazing to me. I'm always astonished every time I hear things like this.
Yeah, it's super neat.
Okay.
It's all from the
So, Tom, how long will this last?
Sure. So
yeah, I see that. How long will this last?
So right. So usually La Niñas or El Niños can last a little less than a year, a little over a year, depending on, each event is different. They're all kind of like, think of them as like relatives. They're all cousins to each other. They're like similar, but they're their own person. Well, in this case, their own El Niño or La Niña event, but they can last around a little less than a year, a little over a year or so, or even a little bit longer than that. And El Niños and La Niñas happen generally every 2 to 7 years. across the Pacific. So it's not something you'll see every year, but when you do have one happening, it can have big impacts across the world and across the United States.
Yes, yes. And so how do you know or recognize when La Nina is occurring?
Sure. So there's a couple of things you look for. So a lot of times when we're talking about, this is known as a climate phenomena. And so when you're looking at climate phenomena, you're often looking about like what's different than normal. So the first thing you'll notice about what's different than normal in a La Nina is you'll start to see that the ocean temperature, the surface temperature of the ocean across the Pacific is starting to get cooler than it normally is. So it's starting to get colder in the central and eastern Pacific Ocean. Meanwhile, way off in the western Pacific Ocean, across like the Philippines and Indonesia, the waters actually are getting warmer than they normally are. That's like the first sign. And the second sign, or basically the first and second sign are kind of interchangeable, they can happen in both directions, is that the trade winds that blow constantly along the equator, they blow from the east to the west. Those trade winds during La Nina get stronger. So they push more and more water across the Pacific Ocean. And once that gets locked into place, you'll start seeing this broad change in the way the atmosphere normally works in the Pacific Ocean. And once you get those two things, you got the ocean, you got the atmosphere locked in, then scientists can be more confident that we have a La Nina event. You need kind of both things to be happening. It takes two to tango, and that includes the ocean and the atmosphere.
So one person asked, are we heading into a La Nina this year?
We're not only heading into a La Nina, we're in a La Nina right now. We are right in a La Nina. We announced it last September. Good question. We're currently in a La Nina right now. And that's expected to last through this winter and into next spring, too. And that could have an impact on what we see weather-wise across the United States this winter.
Wow. Oh, I'm glad you brought up this winter, because there was actually a question about this winter, and I'm just going to make sure I find it so I ask the right question. What does this winter look like for Canada/the U.S. Northeast?
Sure. So I was just taking a look at this before earlier today. I was looking at this because I was also curious. I love the snow, so I'm always curious about what the winter is going to be. So just so you know, the folks in the National Weather Service across NOAA who make our seasonal predictions are the folks at the Climate Prediction Center. They will be releasing their next winter outlook on October 15th, I believe, the third Thursday of October. So I'll leave the forecast out to them because they're the experts. That's what they do. But in general, what I can say right now, based upon the most recent forecast that came out, is that it generally looks to be potentially warmer than average across the southern tier of the United States and cooler than average across the northern tier, and that kind of flips when you look at the precipitation as well. Drier across the southern part of the United States and then wetter across the northern part of the United States. But importantly, that forecast can change. So you'll want to be paying attention to what the Climate Prediction Center says in October and in November to get a better idea of what may be in store for our winter this year from December through February.
All right, and then I have one more question before we wrap this particular segment. There was a question that came in, and it was about if a hurricane is in the middle of the ocean and doesn't touch land, is it a tsunami? So can you just talk about what a tsunami is and the difference between that and a hurricane?
Sure. So a tsunami is kind of an ocean wave. It's a really long wave, but it's in the ocean. It's not really a weather event or even a climate event. And tsunamis can be formed a lot of different ways. You may know them from earthquakes. So if you have an earthquake under the water where the earth goes like this really quick, that can set off a tsunami by moving the water like that. If you've ever been in a tub and you do it really quick before, let's say, your mom, not speaking from my own childhood, said, stop getting the water out of the tub, Tom, when I was a little kid. That can be one way of forcing a tsunami. Another way is if a whole bunch of stuff like a rock slide happens into the ocean. And that could also push water and create a tsunami. So that's mainly just talking about the ocean waves. A hurricane is a weather event or a climate event, depending on how many numbers you look at. But they're a weather event. They're clouds, so they're above the surface of the ocean, although they use the ocean for their strength. So a hurricane is in the middle of the ocean, still a hurricane.
Gotcha. Thank you. I appreciate that. Okay, so Tom, can you talk a little bit and just share how you feel about your job and why you think it's important to share this information with others, because that is your job, right? To communicate about this type of work.
Sure. Yeah, I've wanted to talk about the atmosphere since I was in 3rd grade. I've loved clouds since I was a very little kid. I was one of those weird children. I would say not weird. I was curious. I love thunderstorms. I was a kid that my mom would have to come and drag me inside when there's a thunderstorm because it's dangerous. Do not go outside during thunderstorms. You should be inside. So I've loved the atmosphere since I was really little. And one of the really things that now I love it even more, I still love the atmosphere. One thing I love the most about it is talking about it to people, because I want people to be prepared to know what's happening so they can make the best decisions for them. It's a fun thing for me because I get to share something I love every day and actually see it make a difference to people, so that they can be safe and they can keep their family safe and their community safe. And that means everything to me.
Great, thank you. And thank you for the work that you do. We really appreciate having you on. Thank you, Tom. And so now we're going to watch a video about how climatologists monitor El Niño.
El Niño and La Niña are periodic weather patterns resulting from interactions between the ocean and the atmosphere in the tropical Pacific Ocean. Ocean temperatures indicate the presence of El Niño and La Niña, which sometimes lead to extreme weather in many parts of the United States. NOAA climatologists closely track the development of these oscillating systems, which typically last between 1 to 2 years. With so much at stake, it's critical to be able to monitor and forecast when El Niño or La Niña is developing, so governments, businesses, and private citizens can prepare. NOAA gathers data from an array of buoys and satellites that measure ocean and air temperature, wind speed, and direction. But there's more to the story. Emerging technologies are being tested to measure ocean temperatures and salinity, including low-cost, easily deployed pico buoys, which have instruments that use wave energy to climb up the mooring line, then take measurements during descent, and underwater gliders that fly like a roller coaster on autonomous missions that can last 3 months or longer. With this information in hand, NOAA's Climate Prediction Center tracks and forecasts the development of El Niño and La Niña. Historical and real-time weather data are collected, and a team of climatologists piece together a probabilistic forecast months into the future. And since we are continuing to develop and implement new observing technologies and gain more skill at predicting weather and climate, why not take advantage of this freely available information from NOAA, the nation's environmental intelligence agency? Because remember, El Niño and La Niña in the Pacific Ocean can impact weather and climate in your backyard.
All right, great. So now we are going to be joined, as you see, we have Tom back. Now we are also going to be joined by Dr. Gerry Bell, who is a hurricane climate specialist and the lead seasonal hurricane forecaster at NOAA's Climate Prediction Center in College Park, Maryland. Welcome, Dr. Bell.
Oh, hi, Simone. It's great to be here to talk about hurricanes today.
Yes, it's such a pleasure to have you with us. And of course, you see that we have Tom here. So since you're going to be talking about hurricanes, we'll make sure that we try to direct some of the other questions that we have towards you. All right. Sure. So, perfect. So, as you have observed El Niño and La Niña, and it's something that your team likely does, often and every year to produce the seasonal hurricane outlook. Can you tell us what types of things you normally look for?
Sure. El Niño and La Niña not only affect the weather across the United States, but they also affect hurricane activity around the globe. And one of the main areas of hurricane activity is the North Atlantic Basin, and we're especially interested in that because those are the storms that threaten the United States. So there's several things that we look at and want to know when predicting for the overall hurricane season what the activity may be. Those include things like the strength of El Niño or La Niña. whether you have an event at all, whether that event is strengthening or weakening. All of those come into play as far as trying to then predict what might be its impacts on the Atlantic hurricane season. So to do that, there's several things we look at. As you saw in the video, looking at the ocean temperature departures from averages is absolutely crucial. And that's the ocean part of our monitoring, but the atmospheric part is also critical. We look at things like the trade winds. You want to see stronger trade winds, but most importantly for the hurricanes, we want to see if the patterns of tropical rainfall across the Pacific have been altered. And that's why El Niño and La Niña's impacts are so global, is because they directly affect the tropical rainfall patterns across the entire Pacific basin. So based on that, we can then help to assess La Niña. For instance, this year we have a La Niña just developed. We can look and then predict what will La Niña's impacts likely be, giving this entire coupled ocean atmosphere phenomenon that's now in place. So it's more than just looking at the ocean temperatures, it's looking at that rainfall to see how the impacts can extend way downstream over the Atlantic to affect the hurricanes.
Okay, got you, I understand. And so, I guess one question that I actually have, and others might be thinking it, are there any benefits to hurricanes, or do we feel like they are, storms that you might cause, some negative benefits, but are there any negative benefits, some negative impacts, but are there any benefits to them?
It turns out that tropical storms and hurricanes are important sources of moisture for both the Gulf Coast and the East Coast of the United States. Problems come in when you've got excessive rainfall, which when you have a slow-moving tropical storm or hurricane, it can produce 20, 30, 40, 50 inches of rain and cause tremendous flooding. Obviously, that's not a good thing because millions of people are impacted. But the one benefit that comes to mind is just overall more rain, and that can help to bust drought if there's droughts in Florida or the southwestern U.S., things like that.
Yes, someone said water is life, and I feel you. Yes, water is life. So it's great that we are talking about this. Thank you for that, Gerry. There's another question that I have. So on average, how many storms form during the Atlantic hurricane season?
Well, on average, and that's if you look back over the last 30 or 40 years, we see about 12 tropical storms per year. About 6 of those become hurricanes, and about half of those, 3, become major hurricanes. And that's those strongest hurricanes with wind speeds of 111 miles per hour or stronger. And that's those ones that get the category 3, 4, and 5 ratings that you hear about on TV.
Wow, wow. So we may not even, and we kind of probably know this, but we may not hear about every hurricane, right?
Well, we hear about them in different ways, but our biggest, when we hear about them most in the United States is when they're threatening. Fortunately for us, a lot of storms do stay offshore. Some stay well out in the ocean and really don't impact the Caribbean islands or Mexico or the United States. And so we really don't hear too much about those. They're really more of interest for ocean people and ocean vessels and things like that. Where we hear about them most is when they're potentially going to affect the United States.
Got you. All right. So we might have, you said that usually there's about, 12 storms on average, but have we seen more this year? And if so, what conditions in the ocean might have helped to set this up?
Well, this year we're in the middle of a very active hurricane season. This year we've already had 23 storms. So that's way above the average of 12. The strongest hurricane season on record was 2005 when we had 28 named storms. So we're way ahead of the average this year, and we had expected that this would be an above normal, potentially extremely active season. And so there's a couple of factors that have been involved as far as the ocean goes. One is that we've been seeing well above average sea surface temperatures across the tropical Atlantic Ocean, the Caribbean Sea, and the Gulf of Mexico. And in generally, warmer waters provide more moisture and more heat to a storm, and they provide the potential for more development. Now, the other part of the sea surface temperature pattern is over in the Pacific, where the temperatures in the eastern half of the tropical Pacific have been cooler than average. That has resulted in a La Nina episode, and La Nina also favors more Atlantic hurricanes. So that's that downstream impacts again. When we have a La Nina, that favors more Atlantic hurricanes. When you have an El Nino, that tends to suppress the Atlantic hurricane activity. So by monitoring and predicting El Nino and La Nina, that really helps us to assess what the upcoming hurricane season might bring.
Interesting. Also, we've been seeing more active Atlantic hurricane season, right? You mentioned that we've been pretty active, and this has been since about 1995. Can we talk a little bit about why that is?
Sure. It's really important to understand that there's a lot of variability in hurricane numbers, not only from year to year, but for decades at a time. For instance, on average, if you look back to the historical record, we see 25 to 40-year periods where there's more activity, followed by 25 to 40-year periods where there's less activity. Since 1995, we've been in one of these more active hurricane periods, and we call that a high activity era. So we're 26 years now into that. 70%, 7 out of 10 seasons on average since 1995 have been above normal. That's a lot of activity. So we've been seeing, as we're again this year, a lot more storms and more stronger, longer-lived storms and hurricanes since 1995. It turns out that the reason for that is that there's another climate pattern that comes into play. And that climate pattern varies on timescales of 25 to 40 years. Hence, it affects hurricanes on those timescales. And what this pattern is related to is the Atlantic Ocean temperatures. What we see is warmer ocean temperatures for 25 to 40 years at a time, producing more hurricanes, and then cooler ocean temperatures, producing fewer hurricanes. So for instance, the 1950s and 1960s were really active. We've been really active since 1995. And in the intervening period from 1971 to 94, we saw a lot less hurricanes, major hurricanes, and a lot fewer storms making landfall. So this is another climate pattern that's, again, reflects this ocean-atmosphere link-ups where things that are going on in the ocean ultimately affect the wind patterns, air pressure patterns, and therefore affect the weather. In this case, that weather being hurricanes, hurricane strength, duration, and so on. So when we make our hurricane season outlooks, we're looking at a combination of this pattern that lasts anywhere from 25 to 40 years and the El Nino La Nina cycle. We want to monitor and understand them both, because ultimately predicting these climate patterns is what gives us confidence to predict what the overall hurricane season will be. It's really amazing.
Yeah, right. It seems like, again, it's talking about interconnectedness, right? Like all of these things kind of depend on one another. So I'm going to pull up a question from the audience. One of them was, with all of the stronger phenomena that we are living in these days, is there something that we can do, or should we just adapt? And this is for either of you, I would assume.
Yeah, there's a lot of issues related to adapting to not only more hurricanes that we're seeing, but changing hurricane impacts, for instance, due to global warming. With global warming and warmer ocean temperatures, warmer waters actually make the sea levels rise. That means the sea level will start encroaching more and more on land. So if you're an immediate coastal resident, you need to be very concerned about that. This becomes a problem for hurricanes because hurricanes can really whip up that ocean and drive it far on shore. And when it does that, it's called a storm surge. And we need to get people out of that area because you don't survive storm surges. So with rising sea levels, that becomes a problem. We really need to make sure people get out of the way. But there's another issue in that our coastlines have built up so much over the last 30 to 50 years so that there's so many more millions of people in harm's way every time a storm threatens. So it's not just more hurricane impacts, but it's more people being potentially impacted. And that's why hurricane preparedness is so key every year, regardless of what we're predicting for the season, because we all know, and we saw this year with 9 landfalling storms already, it only takes one storm striking your area to make for a very bad year.
Yeah. So I love that Tom is like doing he's like one sea level rise. He's doing some great annotations in the background. And you actually hit on another question that someone had, so you've already addressed it. You hit on one of the questions about sea level rise and how that is connected to or impacted by hurricanes. So since you kind of introduced us to storm surge, I'm going to throw to our very last video, which is about hurricane storm surge.
Powerful winds aren't the only deadly force during a hurricane. The greatest threat to life actually comes from the water in the form of storm surge. Storm surge is water from the ocean that is pushed toward the shore by the force of the winds swirling around the hurricane. This advancing surge combines with the normal tides and can increase the water level by 30 feet or more. Storm surge combined with waves can cause extensive damage. It can severely erode beaches and coastal highways. The pounding waves can take out boats and buildings. As the waters move inland, rivers and lakes may be affected and add to the rising flood levels. While we can't prevent storm surge, we do have a system that can warn us of the incoming threat. As a hurricane develops over the open ocean, forecasters at the National Hurricane Center closely monitor its path to evaluate the risk of a coastal strike. They use a computer model called SLOSH to predict storm surge heights. The model depends critically on the hurricane's track, intensity, and size. SLOSH uses water depths, land elevations, and barriers to the flow of water to compute surges as they move inland. This data helps determine which areas may need to be evacuated. When a hurricane slams our coast, it's important to be aware of all the dangers. As a reminder, emergency managers want us to run from the water and hide from the wind. Don't take unnecessary risks during a storm. Conditions can change in the blink of an eye. Storm surge is a dangerous event during a hurricane, where furious winds are driving deadly flows of water from our seas to our shores.
All right. So, Dr. Bell, similar to what I asked Tom about, what does he enjoy most about his job? How long has he been doing this type of work? Can you give us some of that information about you and your career history?
Well, sure. I've been the lead seasonal hurricane forecaster at NOAA since we began issuing these seasonal outlooks in 1998. And there's just been a tremendous evolution in our understanding of the climate patterns that I was talking about and how they control the hurricane activity, and also in the development of the weather and climate models. It's only been about, since 2008 that we've been even able to use climate models to help make the seasonal hurricane predictions and better even assemble all the tremendous millions and millions of pieces of data that we need to even begin to make a hurricane forecast for a single storm, let alone a seasonal hurricane outlook. So the evolution of the science has really been exciting and tremendous. And another thing that I really like talking about is the hurricane preparedness, because so many millions of people are potentially impacted by hurricanes. In fact, when we issue the outlooks, really the most important message is not the outlook, it's, hey, you need to get prepared for the hurricane season. And part of that is that we know hurricanes are not just a coastal event, because we see slow-moving, long-lived hurricanes move well inland, up the Tennessee Valley or up the entire east coast of the United States. So even though you may not live directly along the coast, we all know you could certainly be impacted by a hurricane. Maybe it's through significant flooding or down trees and power lines, things like that. So there's so many different ways that people can be impacted. And when I do interviews and things like that, I like talking about that, because getting prepared for the hurricane season is the most important thing that people should get from the hurricane forecast that I make.
Great. Thank you so much for your work and for sharing it with us and for helping everyone to become more prepared, right? And so I really appreciate you joining us today.
Thank you, Simone.
Of course. And Tom, thank you for joining us as well. It's been really great to have you. Do you want to leave our audience with any words or anything you want to stick out to them?
I'll just say one thing for folks who don't know. Dr. Bell is one of the world's foremost experts in this, and he's someone who I've looked up to. You probably don't know this, Gerry. You're someone I've looked up to for a very long time. So it's been a pleasure to be able to say I was on the same call as you, because he is someone who I've gone to numerous times. When I say I don't know something, the person I usually go to is Gerry to give me answers. So thank you so much for having me, Simone, and it's been great being on the same call as you too, Dr. Bell.
Well, thanks, Tom.
It's been a pleasure. Yeah, thank y'all so much. I really appreciate you being with us. This has been a really great show, everyone. And the time has flown by, right? It's already been an hour. So we're going to wrap up our show, but I just want to say first, please visit our Hurricane Survival Guide collection every year to refresh yourself on how to get ready for the next big storm that might be coming. After the show, please take our post-show poll. This will help us to improve our show and produce the kind of programs that you want, since we are doing these shows every month. And so we want to say thank you for attending the watch party. We will be sending you a certificate, of course, so that you can show that you have joined us. And we will send a link to the archive as well, so that you can have access to this video and the resources that we've mentioned here. And so thank you so much for joining us, and we hope to see you next month, where we are doing Creep into the Deep, the Halloween special. This is a good one, y'all. Have a good one, everybody. Bye-bye.